So almost finished with the test. I will get them finished before I go home today. I just have one page left. So they'll be on Canvas later today. And then maybe, yeah, we should be ready to let you see them Wednesday. Okay. Yeah, the score will be on Canvas today. Okay. So here's sign in. Okay. All right, so we are moving into chapter 8. Okay. If you don't like doing calculations, chapter 8 is a good section for you because there's not a whole lot in chapter 8. In 8.1, I don't think there's any calculations. Okay. So that's good if you're not a number crunching fan. Okay. Chapter 9 will make up for it, okay, unfortunately. But yeah, so this section we don't have to do a lot of number crunching. Okay. We are delving off into a little bit of statistics in chapter 8. Okay. In 8.1 specifically, we're going to talk about collecting data and different ways we do that. Okay. Before we get really into that, we got vocabulary to go through, and then we'll start working on that. So we're going to do 8.1 and then may finish 8.2. We'll at least do part of 8.2 today. We'll see how it goes. Okay. So got you bribed with candy, so maybe that'll help a little bit. Okay. Okay. Anybody have anything else we need to talk about before we get going? Good. Okay. All right. So our main goal, okay, in this section is to be able to tell the difference between some different sampling techniques. We've got a few minutes before we get there because we've got vocabulary to go through, but that's our big goal in this section. Okay. So the idea, okay, when we're dealing with statistics, okay, is that we have some type of question we want answered. We have something we want to know that can be answered with some type of number. Okay. And we can use statistics to answer those types of questions. That might seem kind of limiting, that it has to deal with some kind of number, but it's really not that limiting, because a lot of things that we want to know like what percentage of people do this or what percentage of people do that. So that's a number. Right? So it's widely used. Okay. The process to answering our question, okay, starts off with collecting some data, and then we go from there. So this section focuses on different ways we collect data. The question that kind of motivates some of the examples in this section is maybe we want to know something about which type of car gets the best gas mileage. So that's one thing we could answer. Okay, so before we can get into this, we've got some vocabulary to run through. Sorry about that, new chapter, that kind of just part of it. Okay. So our first term here is population. When we're in the context of statistics and we talk about a population, we just mean whatever group we're trying to answer a question about, or whatever group we're studying. That's our group of interest. In statistics, population doesn't necessarily mean living things, right? And doesn't necessarily mean people. And if we want to know something about the average amount of potato chips that's in a potato chip bag, then all the potato chips coming off an assembly line might be our population. Okay? It doesn't have to be people or living things. But the big takeaway here is that the population is the whole group that we want to know about, right? The whole group that we're studying. So if we want to know something about a group, okay, we said the first thing we do is we collect data. And easy definition here, data is just information. It comes in lots of different forms. It's just our information that we're collecting. Okay. So the easiest and the most direct approach, if we want to know something about a population, okay, the best way we have to answer that question we have about our population is to collect data from every member of our population, and then we can just answer our question. If we do that process, that's what we call a census. So the big feature of a census is that it collects data from every member of the population. That's what makes a census a census. The United States just did a census in 2020, do one every 10 years. The idea there is that they go around and collect data from every person in the country. In practice, that probably doesn't happen. There's probably people that are missed. Okay, but that's the motivation. That's why we call it a census, is we're trying to get information from every person. So if we go through that process and we do collect information from every member of our population, then we can take our data and boil it down into a number. Okay, several ways we can do that. Boil it down into a number, and that numerical description of our population is called a parameter. So let's think of an example here. So if my population were just students in this room, okay, that's the group I want to know about. Maybe my question is, what percentage of the students in this class are commuters? Okay. Then what we could do is we could go around to each person, okay, and collect information on whether or not each student in here is a commuter or not. And then we can come up with a number. We would have some certain percentage of students are commuters. And since we took a census to get that number, we would call that number a parameter. So that's our most direct approach. And it's the best way to answer a question about a group if we can do it. But quite often, okay, it's not practical to do a census. Okay? If our population is only the size of the students in this room, it's not too bad, right? We can just go around in the class period even and get information from every person. But if we're thinking like the United States Census, right, this around 330 million people you're trying to collect information for. Okay, so doing a census can be really expensive. Okay, it can just be generally just very impractical. Can take a lot of time. Okay. Well, there are lots of reasons why we can't always do a census. And so instead, taking data from every person in the population, okay, what we do instead is we collect data from a sample. So a sample is just a part of a population. It's just a subset of a population. So instead of collecting data from everybody in the population, we just collect data from part of the people, if we're thinking people. Okay. And once we've collected our data from our sample, we can come up with our numerical description of what's going on in the sample, and that number we call a statistic, a sample statistic. So this is the same idea as parameter. The only difference is where our information comes from. With a parameter, our number is coming from the whole population. With a statistic, our number is only coming from a sample of our population. So that's one theme we have in statistics, that we may have numbers that are similar type of number, but it's really important for us to distinguish where those numbers came from. Did it come from the whole population, or was it just from a sample? Because we end up having to treat those numbers differently depending on where they came from. Luckily, our terms here are easy to keep track of, because let's get a color here, a statistic comes from a sample. And they both start with S. So sample statistic. And if we go back to our other term, a parameter tells us about a population. They both start with P. So population parameter, sample statistic. Okay. So that's most of our upfront vocabulary. Okay. If we need to know. All right, so we also have a little summary slide here. We won't spend much time on it, but just really quick review. Right? The big group, the whole group we want to know about is the population. We just take part of that, that's our sample. If we have a number describing the whole population, we call that a parameter. We have a number describing a sample, we call that a statistic. Okay. These last two are a little more subtle and we won't get off into them. Okay, we don't have to get into all the little details in this class. All right, so let's look at a couple of examples here. We're just using our vocabulary. We've got a couple of survey reports. We want to pick out the population that we're studying, okay, the sample that we've taken, and then the result that we're given, we want to know, is that telling us about the sample, so it's a sample statistic, or is it telling us about the whole population, it's a population parameter? Okay, these can be a little tricky if you haven't thought about these before. Okay. Let's look at A. A says a headline about the rising obesity among young people led a school board to survey local high school students. Out of 231 students surveyed, 58% reported eating a high-fat snack at least 4 times a week. Okay. So who are we studying here? What's our population? Be a little, yeah, we're in being a little picky there is local high school students, right? That's the people that we want to know about, so local high school students to this area. Okay, so out of those, which ones are our sample? What would we call our sample here? Yeah, the 231 students that are in our survey, that's the sample we're taking. Okay, we're surveying these 231, so that's our sample. And then this number, you can kind of forget about the stuff that comes before this, okay? Just focus on this little piece, okay? It says 58%, well, it says out of 231 students surveyed, 58% reported eating a high-fat snack, blah, blah, blah. So is this 58%, is this telling us about the whole population or just the ones in our sample? Just the ones in the sample, right? It just says 58% is telling us about the ones in the survey. Okay. So since that 58% is telling us about our sample, we would call that 58% a sample statistic. That would be a statistic. Okay. Questions on? A little weird till you get the little practice in picking the pieces out. Okay, let's look at B. B says a nonprofit organization interviewed 618 adult shoppers at malls across Louisiana about their views on obesity in youth. The resulting report stated that an estimated 48% of Louisiana adults are in favor of government regulation of high-fat fast food options. Okay. So, who are we studying? Yeah, adult shoppers. And we can even be a little more specific. We could say adult shoppers in Louisiana. Yeah, adult shoppers is good. And that's the group we're studying. Okay, so what's our sample that we're taking? We got some interviewed. How many of those do we have? Yeah, 618. Now we had 618 people that we interviewed or that they interviewed. And so that is our sample, the 618 adult shoppers that were interviewed. Okay, Now this one's a little weird. Forget about the first sentence. Let's just read what it says. Okay. It says the resulting report stated that an estimated 48% of Louisiana adults are in favor of blah, blah, blah. So is that 48% just telling us about the ones in the sample, or is it telling us about all of our population? Yeah, the whole population, okay, because we saw when it was telling us about just the ones in the sample, it would be worded like 48% of adults interviewed or something like that, right? So this one, since it just says 48% of Louisiana adults, right, that's talking about all of them. Okay. So this number is telling us about the whole population. So we would call this a population, what, you remember? Parameter, population parameter, yeah. Okay. Good. All right. Questions on those? Just going back to that vocabulary. Okay. All right. So the main thing we're after in this section is different ways we collect data. Okay, different ways we can take one of these samples. Okay? And the big idea is that ideally, when we collect a sample, our sample would look just like a little version of the whole population that we're trying to study. So what I mean there, the same types of people you have in the population, you want all those in the sample, and ideally in the same proportions and all that. So we just want our sample to look just like a little mini version of the whole population that we're trying to study. Okay? If we can get that, okay, if we can attain that, we get what's called a representative sample. Okay? So that's what we want whenever we collect a sample, and our definition here says it has the same relevant characteristics as the population, and then a big thing here, it does not favor one group of the population over another. Okay. If that's the case, okay, this part, if our sample favors one group of the population over another, we would call that bias. Okay. So another way of talking about our sample, we could say we want our sample to be non-biased. So thinking about this and why we don't want our sample to be biased. So maybe we're taking a poll to figure out the most popular college sports team in the state of Alabama. Okay. All right. So we're trying to collect a sample that represents all the people in the state of Alabama. Do you think we might favor one group of the population over another if we collected all of our data on the campus in Tuscaloosa? You think it might be kind of favoring one group over another if we did that? Probably. Or if we went on around the campus of any of the other schools, really. It's not just one in particular. So we wouldn't want to do that, okay, because we wouldn't want all of our sample to be people that we're pretty sure are going to be fans of one college, right? Because we don't want to have bias. Okay. So we want our sample instead to look like to be mixed, okay, the same way that the whole population is. Okay. So doing this, collecting this representative sample can be a lot trickier than you might imagine. Okay. There are lots of times when we're biasing our sample toward one group or another without realizing it, and there's things we don't think of sometimes, and so that kind of puts a lot of layers into trying to be really careful that we minimize bias as much as possible. Okay? And because of that, we have several different techniques that we use when we collect sample data. Okay? So that's what we're going to look at in the rest of this section, is some of the different techniques we can use to collect a sample. Okay? All right, so our first sampling technique, okay, is just what we call a random sample. Okay? And the idea here is that every member of the population is just as likely to be chosen as any other member of the population. Okay? We're just picking members of our population at random. So we're thinking there, if we are just randomly picking members of the population to be in our sample, then hopefully we don't have any kind of pattern, or we're minimizing bias that way. It's a random sample. Okay. All right, number 2, our second sampling technique we're going to talk about. It's called collecting a stratified sample. Okay. All right, this one's a little more involved. Okay, so let's try to get the picture of what's going on here. Okay. It says we're taking the members of the population and dividing it into 2 or more subgroups. Okay, and those groups we're calling strata. That's where we get the name stratified. So strata just means like a layer, right? And the idea is that the way we come up with our subgroups, or strata, is that we're going to put members of the population that have similar characteristics together. Okay? So maybe we're going to split our population up by age group, okay? Or something like that. And then we take a random sample from each one of the layers, each one of the groups. So the intent behind that is if we split our population into age groups and then collect some data from every age group, we're making sure all the age groups are included in our sample. Okay. We've got one that's similar to this in a minute. Okay. So to keep from getting confused, okay, we're putting our subgroups together with similar characteristics, okay, and then we're collecting a random sample from each one of those subgroups. Okay. So let's stop and think about that in a minute. So if we're thinking about gas mileage, right, was our motivating question our textbook gave us. We want to take samples of different cars, okay, so we can answer which one gets the best fuel mileage. What are some different ways we could group types of vehicles together? Because we want to put them in groups where they all have some similar characteristic. You think anything? What about like if you're shopping for a car online, they've got them grouped together, right? Got them grouped together in different categories. Yeah, so you could do like type of vehicle, so like sports car, SUV, yeah, light truck, and you got all those. Okay. Yeah, well, we probably wouldn't do gas mileage on our particular example because that's kind of what we're studying, but yeah, you could do it in other contexts. Well, you think anything else? You could do color, yeah, if you think that has something to do with has contract, you could do color. You could do year, right? Year ranges for them. Right? You could do price ranges. Okay. And then if we did a stratified sample, what we would do is we would make sure that we collected a random sample out of each one of the categories we came up with. Okay, so maybe we want to make sure we have some SUVs, some trucks, some cars. Okay. That would be stratified sampling. Okay. All right, here's our next sampling technique, and unfortunately it sounds similar to stratified sampling. Okay, so stratified and this one we'll call cluster sampling. Those are the two that are a little tough to remember which one's which. Okay. The rest are not too hard. Okay, so cluster sampling starts off in a similar way. We divide the population into groups, but this time the way we group things is different. Okay, so when we make our groups with cluster sampling, we try to make each one of our little groups look like a little version of the population. Right? So they're mixed. The characteristics are mixed in each little subgroup we call a cluster. Okay? All right, so we get a bunch of little subgroups. They're all supposed to look like the population. And then the idea is that we only pick some of the clusters to be in our sample. We're going to pick a few clusters and use all of the data, all of the members that are in each cluster. Okay, so with stratified sampling, we pick some of the data out of each strata. Okay. With cluster sampling, we pick some of the clusters, but we use all of the data in each one of the clusters we pick. Okay, so it's a little bit different here. Let me try to make us a little sketch, okay? Because these are the two that are tricky to keep straight. The rest are not too bad. Okay, so let's think about stratified first. Okay, get a better color. So the way a stratified sample works is we have our population. Okay. And then we're going to take our population and put it into subgroups. And each subgroup has a similar characteristic, right? So I'm gonna make these look different. And I'll have a square, triangle, circle. I'm running out of shapes here, I don't know. Rhombus, parallelogram, we're gonna call that one, okay? So everything that looks like this goes in this subgroup, everything that looks like this goes in this subgroup. All right, we've got them all with grouped by characteristic. And then what we do is we take some of the data. To get our sample, we take some of our data from each one of these strata, each one of our subgroups. And so we pull some data from each one of the subgroups, and that gives us our sample. Okay. That's stratified sampling. Okay. Cluster sampling, come on, there we go. Cluster sampling, we start with our population. And we divide it into subgroups, but this time each subgroup we try to make it look like the population. And so we'll have little mini versions of the population as our subgroups. And then to get our sample, we randomly pick some of those subgroups. So like we're gonna pick this one and this one. And we take everything out of each one of the subgroups. And that makes up our sample. That's cluster sampling. So if we use the whole subgroup when we pick one, that's cluster. If we take some of our data from all of the subgroups, that's stratified. Okay. Those are the two trickiest to keep straight. Maybe that'll help somebody. Okay, so let's go back to our slides here. Okay, that's cluster sampling. We'll skip over this. Okay. Another type of sampling, another sampling technique, is called systematic sampling. Okay. With systematic sampling, we just have some type of rule, like it says we're going to select every nth member of the population. So maybe we've got an assembly line. We'll say potato chips because that's what I said earlier. We got an assembly line filling bags of potato chips. Okay, then we could say we're going to take every 50th bag of potato chips that comes off the assembly line and put that in our sample. Okay. So we just have some system for how we're picking members of the population to be in our sample. I could say I'm going to go down the rows in here and pick every third person, right, to be in my sample. That would be systematic sampling. Okay. One more here. Last one. That's called a convenience sample. And it's just what it sounds like. Right? A convenient sample is when we pick our sample data just because it's convenient. Okay? It means it's easy, and it's easy for the researcher. Okay? So if maybe we're less serious about having to be non-biased, okay? We're researching some topic that's not so serious, then maybe we could use a convenient sample. So maybe if I'm doing a study on students in this room, I could just pick like people in these two tables because they're the closest ones to me. Right? That would be a convenient sample. All right, so let's see if we can look at a few situations and figure out which type of sampling we've done. Okay. Let's look at these. So we want to identify the sampling technique. Okay. A says to conduct a survey on collegiate social life. You knock on every 5th dorm room door on campus. What type of sampling do you think that one would be? Yeah, systematic. We're skipping 4 doors, and every time we get to the 5th one, we knock on the door and give those people our survey. Okay? So we just have a system, so that one's systematic. Okay. All right. B says student ID numbers are randomly selected from a computer printout for free tickets to the championship game. I think on that one. Have to go back through the list, right? Yeah, this one's just a random sample. So they're just drawing student ID numbers at random. That one's random sampling. Okay. Those are not too bad. Cluster and stratified are really the only two that are tricky. Okay, C says 4th grade reading levels across the country were analyzed by the school board by randomly selecting 25 4th graders from each school in the county district. Okay. So on this one, hopefully you can tell it's either going to be stratified or cluster because we're broken down into smaller groups, right? We're trying to study 4th graders in the county, and the way they're grouped together is by which school in the county they go to. Okay. So we have to think about, would this be stratified or would this be cluster sampling? So it says we're randomly picking 25 4th graders from each one of the schools. And so we're randomly picking some from each one of our subgroups. So would that be stratified or cluster? If we randomly pick some from each one of the subgroups, that one is stratified. Yeah, that one's stratified. And so each one of our strata, each one of our groups would be the particular school that they go to. And we're getting some from each one of the schools. Stratified. Stratified. Okay. D says in order to determine what ice cream flavors would sell best, a grocery store polls shoppers that are in the frozen food section. Yeah, that one, we want to know what people think about ice cream, so we'll just ask people that are standing by the ice cream. Okay. That's just convenience. Okay. Then we've got E, says to determine the average number of cars per household. Each household in 4 of the 20 local counties were sent a survey regarding car ownership. So here our data is grouped together by the county they live in. We've got 20 groups, and we're randomly selecting everybody in 4 of the groups. So which one is this one going to be? Cluster. So we're only picking some of the subgroups, and then we're taking everybody that's in each one of the subgroups that we pick. Okay, so that's cluster sampling. Cluster. Any questions on any of those? No? Okay. All right, that's 8.1. Okay, that's 8.1. It's mainly those different sampling techniques. Okay. All right. Anybody need to top up? Anybody need some more? You need some more? All right. I'm willing to bribe people. Okay. They need any more? We good? Counting calories? May over there need any more? You good? All right. I don't want you to pass out either, so we gotta be smart with our candy usage. Okay. All right. So that's 8.1. Okay. Got it knocked out. Let's look at 8.2. 8.2 is not bad either. In 8.2, we are talking about different types of graphs. Mainly just being able to read these. So not a bad section at all. A lot of these types of graphs you've seen before. So it's not too bad. So the first part of our process, we're trying to answer a question statistically. We collect data. And then in 8.2, we're trying to communicate what we found in our data. And one way we can do that is visually. Not everybody just wants to look at a typed up survey report. Okay? A lot of people would just skip over that if you're trying to communicate your information to them that way. So the idea when we're trying to communicate information with graphs is we want to communicate as quickly and as effectively as possible when we have some type of graph or some type of visual display of data. There are good graphs and bad graphs, and you can talk about what works well and what doesn't work well. That's a little beyond what we're getting into in this class. You can take 204 if you want to know some more about that. I know some of you have to take that anyway. So we mostly in this section, and we just want to be able to interpret what's going on with some graphs. Okay. All right, so first type of graph we're going to talk about, and you might not really think about this as a graph, but it is a visual thing. Okay. It is a visual thing. It's what we'll call a frequency distribution. Okay. And a frequency distribution just splits our sample data, or it could be population data, splits our data up into categories. Okay. Sometimes we have a row, and it's going to look like a table. And sometimes we have a row in the table for each possible data value, or sometimes we group them together. We'll see both of those. But then the idea is we just count how many data values we have for each possible data value. We just put that count out beside our table to let us know how many of those we had. That count we call the frequency of that data value. Okay. So it's just how many of these do we have in our data. We count them, and that's what we call the frequency. So let's look at one. Okay. Semi-interesting. Okay. On this one, we have a frequency distribution that shows the number of crashes with different roadside objects along this road in Washington State. Okay. It won't all fit on one slide. So left side, we've got a row for each different type of object that people crash into. And then over here, we have the counts of how many crashes we had in our data. Okay, so here's some more of the table. In Luminaire is kind of a weird name. That's just some type of, like a light post. The Luminaire. A little bit more. I'm always kind of surprised mailbox is not higher on the list. Maybe I'm not familiar with this area, so maybe it's not really residential or something. Maybe there's not a lot of mailboxes by the road. Okay. There's our frequency distribution. We've got a few questions we want to answer here. Let's see. So question number 1 says, what do the numbers in the parentheses represent? It tells us. Okay. It tells us the numbers in the parentheses are the percentage of our data in that category out of the total data set. Okay. So like here we had 5 people that hit mailboxes. That represents 1.35% of the total crashes. Right? We can go back and look. We had a little over 10% of people in the data crashed into concrete barriers. Right? So that's just giving us a percentage instead of just a count of how many crashes. What's going on there? Okay. Number 2 says, which roadside object was involved in the most crashes? This particular table is in order from most to least, so we'll just go back to the beginning. Our most commonly crashed into roadside object was a guardrail. And had 57 crashes in our data set with guardrails. Okay. And then C, or 3, I've been giving you numbers. How many total crashes did the survey cover? So how many total crashes were in our survey data? We won't go through figuring it out, but how would we figure that out? How could we figure that out? Yeah, we just take the number for each object. We got 57 of these, 55 of these, 42 of these. Just do that for each row and add all those together. Just add all those together. So I won't make you sit here while we add all these up, especially since it's on 3 different slides. That's kind of annoying. But if we do add them all up, let's see, we get 371 crashes in our data. Okay. That's how we can get the total. Let's look at another one. So this one gives us the data. Okay, we've got the number of household pets for 52 different families. Tells us to make the frequency distribution. We're not going to get too into all the details about how you make one of these, like how you pick how many categories you use and all that. On this one, we would just want a row for every possible answer that we had in our data. And then all we do to get the frequency, okay, sometimes people get confused on what the frequency is. So like if our first row was 0 pets, all we do is we count how many people in our data had 0 pets, so how many families. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 families in our data with no pets. So our frequency for 0 would be 16. All we're doing, we're just counting. Okay. And if we did that for 1 and 2 and 3 and 4 and all those, we would get this table. Okay. That'd be our frequency distribution. Okay. So let's answer some more questions here. Well, really just one more. This one just says, what's the most popular number of household pets? 0, yeah, 0. We had 16 households in our data that had 0 pets. That was the most, so that's it on that one. Okay. All right. So typically, when you see a frequency distribution, it's not going to be set up exactly like these last two, where you've got a row for every data value. Typically, that gets really messy, and you know, if you had a big data set, you'd have hundreds of rows. So instead, what's more typical is that we will take different data values and group them together. So like with our pet numbers, we could have said, okay, here's a row for 0 or 1, here's a row for 2 or 3, here's a row for 4 or 5. If we do that, those different groups that we put our data into, the different categories we call classes. If we group our data, we have to make sure that each category has the same width that covers the same number of values. and however wide, however many values or category covers, we call the class width. And these last two terms, the smallest number that can go in a particular category, that's what we call the lower class limit. And the biggest number that can go in a particular category we call the upper class limit. Let's look at one more frequency distribution. This one's, we're going to make a group frequency distribution. Okay. So here we've got data for the number of text messages used per month for 52 individuals. Okay. Until our textbook's getting kind of old, because most of you probably sent way more than that in a month. Okay. There's our data. Okay. And we're not going to we're not going to get into the details of like how you decide how wide to make the categories or anything. Okay. We're in practice, if you want a frequency distribution like this, Excel will make it for you, or you can do it in all kinds of different software. So we won't worry about the details, but here's what we would end up with. So what this is saying is that we had one person in our data that used between 130 and 179 text messages. We had 3 people that used between 180 and 229. 6 that used between 230 and 279. Okay. So just going back to some of our vocabulary, and like these, the biggest numbers that go in each class, those are the upper limits, upper class limit. The ones on the left side are our lower class limits. And then we've got one other thing we might want to figure out, that's the class width. How wide is each category? What range of values does it cover? You have to be a little bit careful how you go about figuring that out, because if you just look like at the first class, you might say that covers 49 different values. You have to be a little careful there. It's actually 50. Okay? And the way to avoid the mistake and the way to find the class width is take 2 upper limits or 2 lower limits that are right next to each other in the table, and then subtract those. Okay? So either take 2 consecutive upper limits or 2 consecutive lower limits. It doesn't matter which pair you choose as long as they're consecutive. Okay? And then subtract, they'll all be the same width. So I'll do an easy one, and I'll do 280 minus 230. We get our class width is 50. Okay. Questions on those? All right, hang in there. We're almost done. Almost done. Okay. Got a couple types of graphs to breeze through really quick, and then one more to talk about, just a little extra, and then we'll be done. Okay, we'll be done. All right, so one type of graph that probably everybody has seen multiple times, pie chart. Okay, so that's when we have the circle, and it's just like cut into slices of a pie. A bigger slice of the pie shows that that category of data is a bigger percentage of the data set. So we won't spend a lot of time there. Another really common type of graph is a bar graph. You've all probably seen these too. The idea with a bar graph, if the bar is taller or longer, right, that means you have more data in that category than in one that has a shorter bar. Again, you've probably seen those, so let's look at one real quick. This one asks people in different generations, do you think the United States is the greatest country in the world, yes or no? And then these are the percentage of adults that answered yes. Okay. So which generation was the most likely to say, yes, the United States is the greatest country in the world? What we got? The oldest one, the silent generation, right? 64% of them said the United States was the greatest country in the world. Again, textbook's getting a little dated. Most of you are not even represented on there. Most of you are starting to be Gen Z. I have a few millennials in here. Okay. All right. One thing that's a little bit less common you may not have seen is if you want to compare multiple groups, you can use what's called a side-by-side bar graph. You don't have to write this definition down or anything. This one's a little technical, so let me just give you the short version. Okay. The blue bars, this thing that says SEER areas, that's people in a cancer group research or in a cancer research group. Orange bars are just the percentages for people in the United States. And remember, if we're trying to do some research, trying to answer some type of question, we want our sample to look like the whole population. So ideally, the bars for both of these would be about the same length. Okay. But if you look at the people in the cancer research group, we've got fairly good bit more percentage of people that were born in other countries than we actually have in percentage-wise in the United States. And then we're kind of what you would say overrepresented by people that have less than a high school degree in our sample in the United States, but the people below the poverty level, that's about right. Okay. And compare the two groups that way. Okay. And then there's also something similar. I don't even have a picture of one of these, so we won't spend much time on it, but another way you can make a comparison is just like the side-by-side bar graph, except you'll see these occasionally where the bars are stacked on top of each other. Okay. And you just have different colors for the portion of the bar that belongs to one group or another. That's a stacked bar graph. Okay. All right, last type of graph here. Our last type of graph. That's called a histogram. Okay. So if we take a frequency distribution like we talked about at the beginning and turn it into a picture instead of a table, we get a histogram. Okay. So we use bars on a histogram, okay, but the bars represent the frequency of the data in each one of the classes. Okay. And one big difference between a histogram and just a regular bar graph is the bars touch in a histogram. That's not that big of a deal. Okay. So let's look at one and answer some questions. We'll be done. Yeah. So look at this one. We have histogram that displays data collected from delivery truck drivers. What's going on is they're recording when they get to a delivery place where they have a closed entrance gate. How long did they have to wait before somebody let them in the gate? Okay. And so like our first bar is 0 to 59 seconds, 60 to 119 seconds. So each bar is a minute wide. We want to answer some questions here. I've got a bigger version because it's a little hard to see. All right, so bless you. All right, so don't give out on me. These are the last ones, but these will help you. Okay, these will help you on the assignment. Okay. A says approximately how many truck drivers were in the survey. This one's a little annoying, okay, but how can we figure out about how many truck drivers we had in our survey? What could we do? It gives us how many we have in each category. I mean, the bar does. So we just have to estimate about where each bar comes to and then add up the number for all of those. So a little annoying because we've got so many bars on this one, but we can do it. We can do it. So this first one looks like it's about 15. What do you think about the next bar? Yeah, maybe 48. Maybe this one's like 28. What do you want to call this next one? 19, yeah, that looks good. What do you think, 18 or 17? 17 maybe. This one looks like it's right on 10. So the next one would probably be 9. This one maybe is another 15. Another 9. So if that one's 9, the next one would probably be 8, yeah. This one's a little iffy. What do you think? It doesn't look like it's quite to 15 to me, so 14, 13, yeah, I don't know, I'll go 13. 19 here maybe. That one, if that other one's 13, I would call this one 14. And then that one maybe like a 12, and then maybe like a 5. Okay. So it's just an estimate. Okay, so let's get them all added up. I'll give you the number I get. Luckily in Hawks, when you're dealing with a histogram, it'll tell you in the description, okay, how many were in the sample, so it helps us out a little bit on that. Because we do need this number for some types of questions we're asked. Okay, so I get roughly, what, 241? Something like that. Okay. All right, so B part says approximately how many drivers waited between 60 seconds and 180 seconds. Okay. So 60 seconds is where the second bar starts. 180 seconds is where the third bar ends. So we want the people in the second bar and in the third bar. So we just add those two together. Okay. Luckily, we've already got our numbers on there. So 48 plus 28, something like that. Yeah. So about 76. What do I say this was? About 241. All right, and C, this one throws us a little bit of a curve. This one says approximately what percentage of drivers waited more than 7 minutes. So to get the percentage, first we need to know how many drivers waited more than 7 minutes. Then we need to divide by how many we had in the sample, our number from part A. Okay? And then we can change it to a percentage. So first thing, we need to figure out how many waited more than 7 minutes. It's in seconds, so that makes it a little messy, but 7 minutes, 7 times 60 seconds would be 420 seconds. So we want, this bar would be 7 minutes, and then going this way would be more. So we would add these bars up. Okay, so let's see what we get there real quick. So 15 plus 9 plus 8 plus 13 plus 19 plus 14 plus 12 plus 5. I got 95. Okay, so 95 out of 241 total. And then we're kind of back to last test. How do we change that to a percentage? Yeah, change to decimal first. So we'll divide by 241. So 95 divided by 241. That's like 0.394 or something. And then, yeah, we'll move our decimal 2 places. So it doesn't tell us how to round here, but we'll say it's about 39.4%. Okay. So the ones where it asks you to give your answer as a percentage, you just take the ones that it's asking you for and divide by the total, right? Change it to a percent. Okay. Questions on those? All right. That's it. That's it for 8.1 and 8.2. If you didn't get on the sign-in sheet, make sure you get on there before you leave. Okay. If you need some more candy on the way out, it's up here on the chair. I will see you Wednesday. Probably.